Imagine cancer cells as opportunistic diners in a bustling restaurant, quietly waiting for the perfect meal to arrive. Most of the time, they are limited by their surroundings, confined to the colon, and restricted by the body's defenses. But a new study in Nature Metabolism shows that sugary drinks, sodas, sweetened teas, and energy drinks provide precisely the combination of ingredients cancer cells crave: fructose and glucose. Together, these sugars act like a gourmet buffet, fueling cancer cells' energy needs, supplying building blocks for growth, and ultimately helping them become more mobile and capable of metastasis. While sugar alone does not initiate cancer, this duo creates an environment that enhances the aggressiveness of cells that are already present, essentially giving them a metabolic advantage for their spread. At the center of this process is the enzyme SORD, sorbitol dehydrogenase, which acts like the head chef converting ordinary ingredients into high-powered fuel. Glucose floods the energy pathways of the cell, producing ADP, the molecular currency of energy that powers movement, division, and survival. Fructose, transformed by SORD, supplies the structural components necessary to build new membranes, nucleotides, and proteins. Together, this combination provides both the energy and the raw materials cancer cells need to move efficiently, survive in new environments, and establish colonies in distant tissues. It's as if cancer cells have been handed a complete toolkit, giving them a remarkable boost in both stamina and resilience. The truly encouraging aspect of this research is the clarity it brings. By pinpointing SORD as the enzyme responsible for converting these sugars into cancer-friendly resources, scientists now have a tangible target for intervention. Therapies that block SORD could disrupt the way cancer cells process fructose, slowing their growth and movement while sparing healthy cells. This represents a major step forward in precision medicine, allowing for treatments that are more targeted and less toxic, directly addressing the mechanisms that fuel metastasis rather than broadly attacking all dividing cells. For individuals, this study translates into actionable lifestyle choices. Reducing sugary drink consumption isn't just a general recommendation for wellness, it is a specific strategy to limit the resources that cancer cells exploit. Choosing water, unsweetened tea, or lightly flavored sparkling beverages over soda reduces the metabolic advantage these cells can access. Even modest reductions, maintained consistently over time, help create an internal environment that is less favorable for cancer progression, slowing the spread before it gains momentum. Knowledge empowers action. By understanding which sugars cancer cells thrive on, people can make informed decisions that influence their internal biology. This study also highlights a broader principle about the connection between diet and cellular behavior. It demonstrates that what we consume influences the microscopic world in our bodies, shaping how cells act, respond, and adapt. By identifying the precise combination, fructose and glucose, and the enzyme SORD as key players in cancer metabolism, researchers have illuminated a pathway where both lifestyle interventions and targeted therapies can converge to reduce risk and improve outcomes. The metabolic menu that once favored cancer cells can now be strategically altered, giving science and individuals tools to intervene effectively. So while sugary drinks may have been cancer's favorite meal, this research changes the narrative from inevitability to empowerment. Understanding the role of fructose and glucose in fueling metastasis allows both researchers and individuals to disrupt the process through dietary adjustments and potential SORD-targeted therapies. Far from a story of doom, it is a story of knowledge, strategy, and hope, a reminder that everyday choices and scientific innovation can combine to slow cancer's spread, protect long-term health, and improve outcomes for those at risk.